बेटा जिस अपने माइक्स जो है ना उनको म्यूट कर लीजिए, ठीक है? अदरवाइज यू विल नॉट। ओके, हाँ। Today we are going to apply another experiment, that is tangent galvanometer. So yesterday actually, I would like to ask one question. I gave you some assignment by yesterday. Uh, have you completed it? Can anybody please tell me?
Yes, ma'am.
Okay. So I hope काफी अच्छी learning होगी आपकी. It will help you to understand the basics as well as the experimental arrangement, right? So today we are doing the same thing, like so again we will go through the vlab.co.in, and then we will go with the physical sciences, and then click on the electricity and magnetism virtual lab of Amrita Vishwa Vidyapeeth. Okay, then click on tangent galvanometer. First experiment, tangent galvanometer. So when you click on tangent galvanometer, you can see theory, procedures, self-evaluation, simulator, assignment, reference, feedback, and all. Fine. So basically here you can see, first of all, you need to go through the theory, then procedure, self-evaluation, and simulator, assignment, reference, feedback one by one. Theory consists of aim, operators, theory, and that. So, okay. So in theory, you can see the formula, and then where we need to basically use the operators. Okay, just to find out or measure in terms of industry. Okay, so this is the part of theory, and then procedure, the steps which were be taken during performing the experiment. Self evaluation is just like a self assessment. So this question will be consisting of theory. So once you read out carefully theory, so you can do the self-assessment also. There you can see some questions, right? So you need to submit that and then go to simulator. And once you complete simulator, then solve the problems in assignment, and you can go through the references also. While you go to the theory, you can read out the references, and these references sometimes basically helps us a lot. Okay, just to understand more and more about the physical concepts and any type of concepts, not only physical concepts, anything else around the theory. And then you may submit the feedback form. Okay, so what is the theory? Here you can see there are two different things actually we have to find out. Number one is a reduction factor of the tangent galvanometer. tangent galvanometer and then find out the horizontal component of Earth's magnetic field. So let's we have to actually determine two different things here. The aim is to find out the reduction factor of the tangent galvanometer, and we need to find out the horizontal component of BH, flux density as a Earth's magnetic field. So when we keep a bar magnet, मतलब अगर हम एक bar magnet to BH, so it will come to the rest by making angle theta with the direction of BH. BH से कितना बना लेगा ये theta angle. Okay. So we know that the tangent law of magnetism says that okay. So now if you go with this is a coil, current carrying circular coil. This tangent galvanometer, if you go with the simulator, so you can see this is a tangent galvanometer. This circle part is basically consisting of a coil which is having N term, right? This is a battery, and you can see here the emitter and rheostat, accumulator, one-way plug key, some connection wires. So with the help of connection wire, we will attach them and close the circuit, and then we can see when the current flows across the current carrying circular coil. So what will happen? Deflection will be measured. Deflections को measure करेंगे. Fine. So again go through with the theory. So this is a rough view of the tangent galvanometer. Again we need to set, this is the circle. So in this circle actually we need to keep the 90-90, and then pointer must be set as 0-0. So these two are pointers, and this is the magnetic needle. When it is set 90-90, so magnetic needle will come to the position of 90-90. That means almost we have set the magnetic needle into the Earth's magnetic field, right? Its north pole will relax towards the south of Earth. Its south will relax towards the north of Earth. Okay, so we need to follow the same process. So what is the reduction factor? We can see here B is equal to mu 0 Ni over 2A. This is 2. Now you can put the value of B here and then write in this formula equation number 1. And then you can see I over tan theta, except I over tan theta, all the quantities will be taken away towards left, and that is actually signifying reduction factor of the tangent galvanometer. Okay, so we need to find out this K value. So let us do that. Application, you can see the principle can be used to compare the galvanometer constants, right? And the magnitude of horizontal component of geomagnetic field. So these are basically the main application, major application. Now, when you go through the real lab, in our physical lab, so we can see the connections once, all the connections made like in this way. E is the battery, A the ammeter, R the rheostat, C the commutator, tangent galvanometer. The commutator, actually with the help of commutator we can change the direction of current. We can keep flow the current in one way as well as the opposite direction. That is the reverse current. Okay. So